Hello everyone. We're going to talk today about a new rule to use when you are taking the derivative. So we're going to start off with talking about what we can do. So we have four examples here of things that we have learned how to do. So for the first function, y equals 2x to the 8th power, of course we can use the power rule. And for gx, we can use the power rule. And we would get that as an answer. And for the derivative of sine of x, you have that memorized, and that would be cosine of x. And tangent of x, you have that memorized, and that would be secant squared of x. So these are all things that you can easily do and we have learned the rules for. So we have a pretty good list of shortcuts that allow us to find the derivatives of simple functions. Now, of course, many of the functions that we're going to encounter, particularly from here on out, are not quite so simple. So what we need is a way to combine the derivative rules to evaluate more complicated functions. And that leads us to the chain rule. So, we're going to start off easy. Consider a simple composite function. We have a composite function, y equals 6x minus 10. That's pretty simple. We can separate this algebraically and rewrite it and factor out a 2 into y equals 2 times 3x minus 5. So what we have there is we have now turned the simple function into two separate functions. If we let u equal 3x minus 5, we can rewrite the original y value into y equals 2u. So now we have our original function, y equals 6x minus 10, and we have our new function where we defined u to be 3x minus 5, so our new function is y equals 2u. So now watch what happens. If I take the derivative of y, I get 6. If I take the derivative of the new y, I get 2. And if I take the derivative of the u, I get 3. And notice that 6 equals 2 times 3. So dy dx is equal to dy du times du dx. That is the chain rule. So let me show you one more, a little bit more complicated, but not a lot. If we let y equal 5u minus 2, if we say u is 3t, therefore, by substitution, y would equal 5 times 3t minus 2. So our big function is on the left-hand side, our simplified middle function, and then our part of our big inside function there, u equals 3t. So if we take the derivative of the big function, dy dt, and we take the derivative of the middle function, dy du equals 5, and we take the derivative of the inner function, then notice that we get 15 equals 5 times 3, and there it is again. That is the chain rule. So here's one more. Y equals 9x squared plus 6x plus 1. So that's our original function. That's the function we want to take the derivative of. We can rewrite that into y equals 3x plus 1 squared. So if u is 3x plus 1, then we can rewrite this as y equals u squared. This is all just simple algebra, just a way of rewriting the function using simple algebra. So now we're going to do some calculus and take the derivative of that function, which is dy dx, take the derivative of y, if it has a u in it, and then take the derivative of the u, and notice that dy dx, the 18x plus 6, is equal to the 2u. So there's the 18x, there's the dy du, there's the du dx, and they're equal. And there it is for the third time, the chain rule. So you want to write that down. That is the chain rule. Alright, so let me give you an example of one that you'll have to do on a test or homework. Let's say we have cosine squared of 3x. We can rewrite that as the cosine of 3x quantity squared. Then, if we take the derivative of the outside, Right, that's the derivative of the outside using the power rule. The 2 comes in front, and then 2 minus 1 is 1, so we wind up just getting 2 times cosine of 3x. Now we have to take the derivative of the inside, the derivative of the cosine 3x. So to do that, we're going to have to use the chain rule again. So if we take the derivative of the cosine of 3x, well, the derivative of the cosine is negative sine of 3x. And then we have to take the derivative of the 3x, which is 3. So you can use the chain rule more than once. That's what makes it called the chain rule. And then you put the negative 2 and the 3 together, and you get negative 6 times the cosine of 3x times the sine of 3x. And the most common mistake on tests and quizzes is to forget to use the chain rule. So here's another example. Let's say we have 2 times x squared minus 3x to the quantity raised to the 8th power. We're going to do u substitution. We're going to let u equal the innermost function. So u is the part inside the parentheses. Find the derivative of u using the power rule. Rewrite the y in terms of u. So y equals 2, and I replace that part inside with a u. Now, find the derivative of y prime. And I wind up getting 16u to the 7th. And then the final step is to multiply them together. And there's your final answer. So just always remember it as the derivative of the outside times the derivative of the inside. Another example. Okay, we have sine of the quantity x cubed. The derivative of sine is cosine, so the derivative of the outside function, times the derivative of the inside function, 3x squared. Put those together. There's your answer. Pretty simple, right? Think of it like peeling an onion. When you peel an onion, you always start on the outside and you work your way in. So on the outside function, identify the layer. So on the outside, we have a cube. This whole quantity is being cubed. So the outside function is the cube. Right, so we're going to, the inside, the very inside is 5x. The middle is the tangent. The derivative would be secant squared. And then the outside is the something to the 3rd power. The derivative would be 3 times that something to the 2nd power. Multiply all the derivatives together, and there's your answer. Now, needless to say, we're going to be doing a lot of practice over the next several days, so if you don't get it right now, you have some good example problems, and you can always watch the video again after doing some practice in class to see where everything comes together. All right. I will see you tomorrow.